Welcome to the video instruction of determining the limit numerically. Okay, so what we're going to do is we're going to go through examples 1 through 3. And you're going to want to have your graphing calculator handy. I'll show you a couple of shortcuts that you can use on your calculator to make this process super smooth and much easier than calculating everything on your own. Okay, so to begin, we're shown function f of x is sine of x over x. Now, just a note here, anytime in calculus when we're dealing with trig functions, make sure that you're in radian mode on your calculator. So you can do that right now. Okay, so first thing that they want us to do here is find f of 0. So finding f of 0, obviously we're filling in the 0, and you're going to get sine of 0 divided by 0. And sine of 0 in radians or in degrees is 0. So you end up with a value that's not a value. It's 0 divided by 0, which is not undefined. It's actually called an indeterminate form. So this was mentioned in a previous video. When you have an indeterminate form, we're not exactly sure what's going on there, so we're going to use the limit to explore what's going on. And the limit is really more interested or less interested in what's going on at that value of 0, which is indicated here in your limit, but what's going on around it. So what are the y values around x equals 0 doing, and what's their behavior? So if you notice in the table, we're going to approach 0 from both directions. This would be approaching from the left, from the negative direction, or negative infinity side, and this would be approaching 0 from the right. Okay, so nobody, and I mean nobody, wants to try to figure out what the sign of negative 0.1 is. And it is an irrational number. And we're going to have to approximate it anyhow. But what we're going to do is we're going to pull up our calculator. The first thing that we're going to do, and I told you definitely go into mode to make sure that you're in radian mode. And then we're going to go back to our home screen, go up to the y equals, and we're going to type in the function in our y equals. Now, please know there are different ways to go about doing this. I'm just presenting one that I like to use. Okay, I'd like to make sure that you know that you can type in a template for a fraction by hitting the alpha y equals key, the top one being highlighted. Once you click on that, will allow you to then type in your ratio and not worry about parentheses. Not that there's anything like that going on in this particular function, but anyhow. Then I'm arrowing down, and here we have it. I'm not going to be so interested in looking at the graph, even though it would give us our answer. Shh, don't tell anybody. We're looking at numerical approaches. Numerical approaches, you need to know that they exist. You can always use them, but probably after we learn everything else, we'll rarely do this. Okay, so now what I'm going to do is, if I want to evaluate these, I would like to pull up my table. So the table is going to be second graph over here. But the problem is that they don't have the input values that we want. So if you don't know this, hopefully you already do, but if you go into second window, which activates your table set mode, and then bring your cursor down to the independent variable and put it in ask mode. What ask mode does now, when you go back to the table, is okay, what happened? It will allow you to, did I not do that? Oh, maybe maybe you need to hit enter, okay? Possibly on this. So anyhow, okay, so now that I go back to the table, you'll see that the input value column there is blank. So we can type in what we want. So the first number on your input table there is negative 0.1. So I'm going to type that in, and then I'm going to hit enter, and it will give you your y value. So go ahead and fill that in. And then you can type in the next one, negative 0.01, and this calculator goes straight to 1, and what it's doing is approximating, but potentially your calculator will give you a little bit more decimally answer, and I would write what you have on your calculator. I'm going to go back to the worksheet and put that in a minute, but I just wanted you to see how you can use your calculator to support this. And so you can type the rest of those in, and then you can pause the video and put them in, or you can wait because I'm going to do the same thing. And so there you go. So right now I'm going to pause the video and I'm going to write all of the values in so it doesn't waste time. Okay, so you should have something similar to this filled in. And now, if you look, obviously at the negative 0.01, we were pretty close to 1. And then you can see these decimals changed only, and then all of a sudden on my calculator, it went ahead and rounded me to 1 on both sides. Notice the values are pretty much the same. This is going to be a little bit of a even function going on there. And so at 0, it's not defined, but do you see that the behavior near 0 is that this is both sides are going to 1. So when we evaluate this limit, we're going to say it is equal to 1 because on both sides they agree and are approaching the exact same number. So that's the first one. Okay, next we're going to go ahead and type this into your calculator. So I'm going to go over here. Remember, when you go back to y equals, we're putting in this ratio. If you want, you can just keep your template there. Oh, I'm trying to click on the screen. That doesn't work. Actually, I'm just going to clear. Oh, it cleared the whole numerator. Sorry, I'm learning things about this calculator. So there's 1, and down below is going to be x minus 1. Okay, there we have it. And if you were to, let me go back to the page here. When you put in 1 on this function, what happens is the numerator is 1, you get 1 minus 1 in the denominator, which gives you 1 over 0. Now this is not an indeterminate form. Anytime that you have 0 in the denominator, that basically means that it's not indeterminate, it's undefined. So division by 0 being undefined. So that's what's going on at 0. Either way, the function is not defined at 1. Okay? So it is not defined. So still we might wonder, hey, it's not defined there, what's going on? And we're going to use our calculator to investigate. So going back to the calculator, again, hit second graph to activate your table. Now what you have in this column, you can go ahead and hit delete, and it'll clear it out. And then we can type in this case, we're not approaching 0, we're approaching 1. So I'm going to put in the first value, which is 0.9, hit enter, and it is at negative 10. And then I'm going to put, what am I going to put? 0.99. So approaching, and then it goes to negative 100. Then 0.999, and then it's going there. Now we can mess around and go, okay, how high can this go? So I can be 0.99999999999. Now if we continued forever, that would equal 1. But as soon as you stop, it doesn't. So so what does this equal? Well, this is negative 1 times 10 to the 9th power, which basically is getting very, very large in the negative direction. So what does that mean for our function? Well, if we put these values in, so we start out at negative 10, negative 100, negative 1,000, do you see that it looks like they are decreasing without bound? So as your x value approaches 1 from the left would be the notation that we would be looking at. So this was kind of, in a way, we're evaluating a one-sided limit. It looks like we're heading to negative infinity, okay? And as we come in on the other side, let's go explore magic calculator. So if I were to put in, what's the first one? So starting out at the outer bound right there. So that's going to be 10, and then going to 1.01. So we're approaching in the other direction from the positive. See how it's going with the same values? 1.001. Let's see, anybody want to make a bet? I'm going to go with 1,000. Ha! I win. Okay, so then, woohoo. So going back to here, you can see that as you approach, so we're going to say it like this, as x approaches 1 from the right, from the positive infinity direction, as I approach, it looks like our numbers are increasing without bound. So what that means is that it's going to infinity. And because of the fact that these two do not match, well, first of all, we're not approaching a number, so this limit does not exist. And if it were the case that they were both going to negative infinity, then we could say, hey, we could respond to this kind of question here by saying it equals negative infinity. Now, I'm not big on saying anything equals infinity, but that's just an accepted kind of way to respond to this. What it implies is that the limit does not exist, but I'm going to give you a little bit of information. It's heading down on both sides. But see how it's not, and if it were positive infinity on both sides, we would say equals positive infinity. But that is not the case. Neither one of these are the case because they don't agree. We can just say the limit does not exist, period. Which also gives information, you know, that we're not approaching the same thing in both directions. Okay, so hopefully that all made sense. Moving on. Now, for this function, see, it's a piecewise function. Notice that you do not have 0 included here. So if you were asked to find f of 0, you'd be like, I don't know. You would say it's not defined. In all of these cases, it is not defined for the value given by design, right? So not defined, we can write it all out. Okay, so you have two choices here. We could do this numerically, or you could actually take a good look at, you know, making the graph. Depends on what you like to do. But if you notice on this, for x values that are greater than 0, which is on this side, that your output is equal to your input. So these are just basically 0, 0, 0, 1, 0.001, 0.01. So it looks like from this side, it's getting smaller and smaller. It looks like you're approaching 0. And you can say that as x is approaching 0 from the right on this limit right here. So if we were looking at this limit as a one-sided limit, and it said limit as x approaches 0 from the right of f of x, you would say that that looks like it is approaching 0, and it is. Okay, now from the left, if you were to go in, we could type this into our calculator and look at these values, or you can do it by hand. It's not that hard. Or you can just wait and I'll give you the answers. Like most of the time, that's the option I would pick. Let the teacher do it. Okay, 0.0001. Okay, so notice these are all not approaching 0. Looks like as my x values are approaching 0 from this time the left, it looks like my f of x is approaching 1. And see, on this side and this side, they do not match. So you would also respond to this saying does not exist. They have to agree, like they did in example number 1. Okay, I hope that's helpful.